So we're now going to talk about implementing and applying Java atomic operations. And I'll explain how they're implemented under the hood and how they're applied. We're going to talk about other applications later, but I'm going to talk primarily here about how atomic operations are implemented. So Java uses compare and swap operations extensively in the Java virtual machine and in portions of Java util concurrent. We'll take a look at some of that code later when we look at the various synchronizers like rantrant lock and semaphore and so on. Here's an example of one method that's provided to do these kinds of things, especially in historical Java. That is Java, I think maybe prior to Java 9. And the particular method we're going to look at is called compare and swap long. And you can see that this is in a class, a funky class called the unsafe class, which is not actually made available to mortals like us. It's only available for Java class library implementers for some good reasons, we'll see. And this is defined as a native method. A native method in Java means its actual implementation is not in Java. It's typically either in C++ or C, but it provides a Java interface. So you can see that this takes Java types, object, long, returns Boolean, and so on. This code here is hypothetical. The actual code, as I mentioned before, would typically be implemented by the underlying operating system, but I'm just going to kind of show it to you here. It's kind of C-like pseudocode, which atomically compares the contents of memory with an expected value, modifies the contents to an updated value if they're the same, and returns the old value. So once again, as we looked at before, when we were talking about this in the previous lesson portion, we have an atomic region, which is implemented by some hardware magic. We take a look, this is really cool. We take a look at we take the object, which is a Java object, which is a reference in Java, and we cast it to a pointer. So it's really a pointer to something, like a pointer to an int. It'd probably actually be pointed to long, but the point is it's a pointer to something. And then we go ahead and we index at that offset from the beginning of the object in order to be able to get the old value. And then we check to see if the old value equals the expected value. And then we go ahead and update this object's offset with the updated value if and only if old value equals expected value. And then we return the old value. So this is very much like we looked at before. It's just kind of showing it in the context of a hypothetical implementation of compare and swap long in Java, just to give you a feeling for what's going on under the hood. Again, this would be typically done in hardware, but this is logically what's going on. So let's take a look and see how you can use these atomic operations, or maybe a better way to put this, how these operations are actually used in practice. So we're going to start off by talking about how the internals of some of the classes in the Java util concurrent atomics package are implemented using things like the Java unsafe class. So this again is only limited to people who are implementing the Java class library, not people like you and me. So this is what's within the Java class library in Java 8 and before. Java 9 does it slightly differently, as we'll see. So here's how this works. And we're going to look at this in more detail later, so I'm not going to talk about it in great detail now. But basically what happens is we store a long value here and a volatile int, because that's all we need. And we go ahead and do some magic using the reflective capabilities of the Java unsafe class to go ahead and get ourselves the offset of the field name value from the start of any given atomic Boolean object. And then we use compare and swap int to do some magic checks. And I'll talk more about this later, so I'm just kind of giving you a high-level view. With Java 9, they added a new class called a VarHandle. And unlike the unsafe class we just looked at, which is only good for Java class library implementers, VarHandles are available for anybody, so you can use it by apps. And as again we will see later when we get into this, you can use VarHandles in much the same way as we use the unsafe class. It's just that this exposes the features of unsafe class in a more portable and type-safe manner that people doing Java implementations thought was more acceptable to the spirit of Java and Java's type system. And again, it uses some reflection and gets access to the offset, and then you can use things like compare and set. And I'll talk about this in more detail as well. So I'm just kind of giving you a high-level view that talks about the different ways over time that Java has provided atomic operations for use by classes at a higher level in the stack.